Hello everyone, welcome to the second lecture of mathematics for grade 10. So we are going to start from chapter 7, section 6, which is about circles in a coordinate plane. So if you recall from grade school, circle is a set of all points on a plane that are a fixed distance from the center. So that's the definition of a circle that you had from early elementary school. So in other words, to specify a circle, you need to specify two things. First, the center, which is in this particular example, the center is fixed at the origin. And then you have to give us a radius, which tells us how far the points are from the center. So in this case, the radius is given to be 5. So the circle is defined to be all these points that are 5 units away from the center. So if you pick any point on the circle, any point, its distance from the center is 5 units. Okay, any point is 5 units away from the circle, from the center. Okay, so that's the definition of a circle. What we are going to do here is to come up with an equation of a circle which has center at the origin, and its radius is r, general number r. So let's see how we can come up with this equation. To do that, we will use Pythagorean theorem. So do you remember Pythagorean theorem? So for your convenience, I'm going to review Pythagorean theorem here. Let's suppose we have a right triangle, something like this, which is right angle over here. Let's say this leg is given by value of A, and this leg is the value B, and this hypotenuse is given by value C. So the Pythagorean theorem reads off like this. It says that A squared plus B squared is equal to C squared. So that's Pythagorean theorem. One of the most famous theorems in geometry. So let's apply Pythagorean theorem here in this circle. So let's say you have a circle which is centered at the origin, and its radius is r. Now pick a general point on the circle, like this one. This point has coordinates of x and y, as you see over here. Well, this point is x units away horizontally from the center, right? Because its x coordinate is x, so it has to be x units away from the center, and its y coordinates is y units away from the center. Okay, so if you make a little triangle here, the triangle is a right triangle. One of its legs has a measure of x, the other one has measure of y, and its hypotenuse will be the radius of our circle, which is r. So you can easily write down the Pythagorean theorem here. So let's see what that becomes. So x squared, this leg squared plus the other leg squared, equals radius squared. And that's it. This is the equation of a circle which is centered at the origin, and its radius is r. Alright, now what if the center of the circle is not necessarily at the origin, but it is in some other point, some general point like A and B in this case? So now we are going to work out the equation of a circle which is centered at some general point like A and B in this case, and has radius of r. So let's see what is the equation of this circle. Well, the situation is pretty much just like the previous case. You pick a general point on the circle, like this one. So it has coordinates of x and y. Now this point is x minus a units away from the center horizontally. Well, that is kind of obvious because this point it has x coordinate, which is x units away from the center. But this point is also a units away from the center. So all in all, this leg over here becomes x minus a. The same reasoning will tell us that this vertical leg over here will be y minus b. So now we can write down the Pythagorean theorem again here. So let's write it. X minus a squared plus y minus b squared equals r squared. And that's it. This is the equation of a circle which is centered at A and B. Let's see some examples. Write the equation of a circle centered at, let's say, 2 and 5 and has radius of, let's say, 4 centimeters or whatever. Okay, so let's write down the equation. All we have to do is to use the general standard equation of the circle. So it is x minus a squared plus y minus b squared equals r squared. So we need to know what is a, what is b, and what is r. So a and b is given to be 2 and 5, so that's the center of the circle, and radius is given to be 4. So all you have to do is just plug in these numbers into this standard equation. So x minus 2, a is 2 squared plus y minus 5, b is 5 squared equals, now radius is 4, so 4 squared will be 16. And that's it. This is the equation of the circle which has radius of 2 and 5 and radius of 4 and center of 2 and 5. Let's see a couple of more examples. Example: what is the center and radius of the circle? So let's say the equation of the circle is given by x minus 1 squared plus y, let's say, plus 7 squared equals 10. Okay, so let's see. Alright, all we have to do is to just compare this equation with the standard equation of the circle, which was x minus a squared plus y minus b squared equals r squared. So now let's compare them. If you compare this part with this part, you will immediately notice that a must be 1. And if you compare this part with this part, well, it's kind of obvious that b must be negative 7, because here you have plus. So in order to get a plus here, this b number must be negative. So that must be negative 7. So let's write that. A must be 1, b must be negative 7. And from this part, the right part of the equation, we'll get r squared equals 10, which means r must be root 10. And that's it. So the center is 1, negative 7, and radius is root 10. And that's it. Let's see one more example. Alright, now for this example, I'm going to make it a little bit more involved than the previous examples. So let's see. Find the center and radius of this circle. X squared plus y squared minus 2x minus 4y minus 4 equals 0. Okay, now as you see, this equation is not the standard equation of the circle. It doesn't look like that general standard equation that we had before. It doesn't look like this one. So all you have to do here is it looks like that it is the expansion of this form. So to get back to this form, we need to factorize this. And in order to do so, we have to complete the squares in the variable of x and in the variable of y. All right, so let's see how it looks like. I'm going to write x terms next to each other. So x squared minus 2x. And then I have y squared minus 4y. And then I have a number negative 4 equals 0. So now if you remember from previous sections, the section for completing the squares, if I want to complete the squares in the variable x here, I need to take b, which is this number, coefficient of x, divide it by 2, square it, and then add and subtract that number. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I have to add and subtract 1. It becomes x squared minus 2x, and then I have to add 1, and then minus 1. And now let's do the same thing for variable y. Well, in this case, for y, b is negative 4. So negative 4 divided by 2 will be negative 2. Negative 2 squared is 4. So I have to add 4 and subtract 4. And then I have a negative 4, which is sitting alone at the end of the equation, equals 0. So now in these three terms, I can factorize, I can complete the squares, which is x minus 1 squared. And then over here, again, I can do the same thing, y minus 2 squared. And now I can add the numbers. Negative 1, negative 4, and negative 4 will give us negative 9 equals 0. Now, it is beginning to look like the general and standard form of the equation of the circle. Now, all you have to do is take the negative 9 to the other side. X minus 1 squared plus y minus 2 squared equals 9. And that's it. You can easily read off center and radius of this circle now. So center is at 1 and 2. And radius, so r squared is 9, so r is 3. And that's it for this video.